Hello students, today we are going to start with Rayleigh's criteria. Now, what is this criteria about? We all know that a diffraction pattern has a variable intensity across its pattern, right? Now, here we have a graph of intensity where we can see and understand how the diffraction is having its amplitude in variation. Just look at the first point here. It's by a distance of lambda by a from the origin, and as the widths are going to be constant, we can say that the next point is going to be 2 lambda by a, and after this it would be 3 lambda by a, and after this it would be 4 lambda by a, and the last one would be 5 lambda by a. But students, this is on the positive x-axis. What about the negative x-axis? It would be exactly the mirror of it, but it would be with negative sign. So I would say this is minus lambda by a, and this is minus 2 lambda by a, and this would be nothing but minus 3 lambda by a, and this is minus 4 lambda by a, and the last one would be nothing but minus 5 lambda by a. The exactly center point is nothing but central maxima, which has the largest width. Right, students? And we can see after that there is first, second, third and fourth maximas and minimas respectively. So students, this is what we are having in our diffraction pattern. But this diffraction pattern is of a single point, which is quite visible. But if the 2 points are very close to each other, then what would be the condition that they are seen separated? So that condition is nothing but given by Rayleigh's criterion. So let us try to understand the first case of it. The first case is if S is equal to delta, that is, it means the separation between central maxima of two objects, which is represented by S here, is nothing but equal to the distance between central maximum and the first minimum of any two objects. That is, S is standing for the distance between two central maximas, and delta is standing for the separation between the first minima and the maxima of either of the objects. So what would happen if this is the condition? We would say that in this case the two objects are just resolved. They are not completely resolved or well resolved. They are just resolved. So how the graphs would be looking like? Here we have the red wave and here we have the blue one. So you can see they are having distance of delta between their central maximas, and as well as the distance is S between these central maximas. In this case both are same, so we would be saying like they are just resolved. But case 2 is like if S, that is distance between central maximas of two wave, is greater than delta, then it means that separation between the central maximum of two objects is greater than the distance between central maximum of the first minimum of any of the two objects. We would say the objects are well resolved. They would look far, right? They would look distinct. So here is my red wave from one particular wavelength, and here is the other one from other particular wavelength. These 2 points are appreciably looking far, right? Why? Because S is greater than delta. Students, this was the 2 cases. There is one more case for this, that is case 3, and case 3 is like if S is less than delta, that is delta is greater than S, which means the separation between central maxima of the two objects is less than the distance between central maxima and the first minima of the two objects. So students, in this case we would say that the objects are not well resolved. They are not just resolved, they are unresolved completely. We can't see the 2 points distinctly. So I can say that the blue wave and the red wave are very close to each other, so that we are not able to distinguish where are the 2 points. So this is given by Rayleigh's criteria, and this is the condition where we understand how the particles are resolved and how the particles are not. So students, here we can state in a statement like we are having 2 point images. So the image of 2 point objects close to each other are regarded as just separated if the central maxima of the one diffraction pattern falls on the first minimum of the other diffraction pattern. So this is going to be the statement or Rayleigh's criterion, student. That's it for this module. Thank you.